Continue. Musa, when we read this question, do you understand every word?
Yes.
Okay. Can you read question 7 then?
One number is 3 times as larger as the other, and the difference between the re
Reciprocals, right? Reciprocals.
reciprocals is 1 divided by 6, and find the two numbers. It means that x plus 3 yeah, no, one number. Yeah.
Okay, good. So now again, Musa, it says that in the question, one number, right? When you just say one number, immediately you ask yourself, what number is it? We don't know. It says that one number is 3 times as large as the other. Okay, we are talking about two numbers. If the first number is x, right? I mean, let's say this is our first number and that's our second number. So it says that one number is 3 times as large as the other. So what is the other number? If the second number is x, the first number should be 3x. And the difference between the reciprocals is 1 over 6. What are the reciprocals of these numbers? It is 1 over 3x, and this one is 1 over x, right? And which number is greater? 1 over x is greater. So the difference between the reciprocals is 1 over 6. That is 1 over x minus 1 over 3x is equal to 1 over 6. So now here the question is, find the two numbers. That means that if we know the value of x, I can actually write the values of both numbers. So that is our equation. That's the most important thing. So the one number is 3 times as large as the second number. So that is the first row. And it says that reciprocals of these numbers, these are this. And it says that the difference between the reciprocals is 1 over 6. That's our equation. Now, since we have algebraic equation, we know how to solve this kind of algebraic equations, right? So the common denominator is 3x. Yes. So multiply the first fractions numerator and denominator by 3. We get here 3x, not 3x. It is 3 minus 1 over 3x. That's equal to 1 over 6. Now, if you cross multiply, 2 times 6, here we have 2 times 6. On the right-hand side, we have 3x. Now, what is x? X equals 2 times 6 is 12, is divided by 3. That's equal to 4. So we are talking about these two numbers then. The first number is 3 times x, that is 12. The second number is 4. Okay. So as you see here, 12 is 3 times as large as 4. And if you take the reciprocals, 1 over 4 minus 1 over 12, that's equal to 1 over 6. As you see, Musa, once actually you get an algebraic equation, the solution part is quite easy. The important thing is how we should understand the problem. You know, understanding the problem is a big problem. So actually now you need to work on your vocabulary and understanding the problem. When you improve your understanding the problem, when you read the problem in the first reading, if you can understand, that is a big step for you. Okay, next thing is we just convert this into mathematical equation and solve it. Okay, Musa, can you read this problem?
The square of x is equal to the square root of y. Express y in terms of x.
Very easy question, Musa. It says that the square of x. What is that? That is square of x is this, right? Is equal to the square root of y. So that is equal to square root of y. So here we have square root of y. What is the question? Express y in terms of x. So now if you square both sides, here we have x to the power of 4. That's equal to y. So dot, dot, dot. Then in terms of x, y is equal to x to the power of 4. Okay, is it clear?
Yes.
Good. Isa, read also this problem and let's solve this together.
A bus travels at 36 km per hour and arrives at its destination half an hour late. If it travels at 42 kilometers per hour, it arrives at the same destination half an hour earlier. Find the journey's distance. It means
Okay.
first speed 36, second speed 42.
All right. Good. So again, here we are talking about the same distance, right? The distance is between two towns. Let's say here we are talking about from A, and here we have, let's say, B. So what is the distance between these two cities or towns? We don't know. Let's say it is D kilometers. All right. So here, let me just write here. If you travel at S kilometers per hour, then you can arrive at your destination in T hours. Okay. But in this case here, we have different scenario. In the first case, saying that a bus travels at 36 kilometers per hour and arrives at its destination half an hour late. That means that this time it's not traveling at its usual speed, right? To some unknown reason, actually, he traveled at different speed. So here the distance is equal to, usually, if he travels at this speed, it takes only t hours to arrive at his destination. So this time now his speed is 36. Now it takes, what is it? Arrives at its destination half an hour late. So that is t plus 1 over 2, right? It takes more time. In the second case, it says that if it travels at 42 kilometers per hour, let's say it travels at 42 kilometers per hour, it arrives at the same destination half an hour earlier. So that is t minus 1 over 2. Maybe this t is actually the scheduled time. All right. Actually, the bus was supposed to travel at s kilometers per hour. At the time it takes t, so it is scheduled like this. But due to some maybe traffic jam or something, in the first case it traveled a bit slower. In the second case it traveled a bit faster. That's our question. What else is given here? Nothing. So find the journey's distance. So we have to find distance from here. So first I will find t, and after that I can find d. Okay. Also directly we can find d from here. But let me just find t first, and after that I want to find d. All right. So since left hand sides are equal, that means that also this 36 times t plus 1 over 2, it should be equal to 42 times t minus 1 over 2. Right. So from here, if you just solve this as simple equation, 3060 plus 18 on the right hand side, 42 times t, it is 42t minus 21, right? Now I take 42 to the left hand side, this 18 to the right hand side, 36 minus 42, that is negative 60, equals negative 21 minus 18, that is negative 39. Now from here, t is equal to 36 over 6, because both sides are negative numbers. By multiplying both sides -1, we can cancel out the signs. So if you simplify this by 3, here we have 13 over 2, which is 6.5 hours. So now if I substitute either into the first equation or second equation, we will get the answer. Let's say that's our first step, and this one is our second step. And third final step would be finding the distance. So distance equals 36 times t plus, what is t? It is 13 over 2 plus half. That's equal to 7. 7 times 6, 42. It is 210. It is 252 kilometers. Dot, dot, dot. The distance between these two destinations or stations, I mean two cities, let's say, is 252 kilometers. Daphne, welcome. Good to see you again here. How are you?
Teacher, for some reason, when I was doing some deep cleaning, because there's a lot of emails in my Gmail, I like for some reason erased the email that my mom sent to me that had this Zoom meetings, whatever it is, like. So I tried to find it for an hour or two before, and that's why I came late a little bit. I found it somehow.
You
I
spent
don't even know
one
how.
hour to find that email?
Yes, teacher, there's so much email. It's because of the Google Classroom. It always sends me like those very annoying notifications from Gmail, and I don't erase them because I don't do anything with them. And then it really annoyed me, so I erased them yesterday. It took me like at least a 3 hour to clean them.
All right, good. Sometimes also cleaning your email or inbox and is a kind of fun stuff, you know. Sometimes also when I feel bored, I just take my hard disk and especially have a look at my old photos, maybe from 2004, and sometimes some not good. How to say, the pictures that are not good of good quality or that I don't like, I just delete them and sort them out. And also sometimes I do this in my emails because there are a lot of emails. It's good. Anyway, the practice solution is definitely, if you cannot, you can just write in WhatsApp group. What is our math classes? What is it? That's password, and the code is very easy. And because I don't change this, I just use my Zoom ID and the same what is it? The same password 12345. Anyway, no problem. You are not so late. That's we were solving questions from review questions 4. We did 2 examples. Okay, now we will continue. A few questions left. Let's just solve them, okay, quickly, and we will finish. Let's see if we have time. We will start a new chapter. Otherwise, we will finish by this chapter. So, guys, again, we are solving a lot of problems related to distance, time, speed, because that thing gives us a lot of ideas solving rate problems. That's why in every math book, this kind of problems are about here. Okay. So Daphne Musa, can you try this problem? But here you have the knowledge. You already solved or practiced a few questions, right? Now we need to work on our speed. Okay. I'm not testing your knowledge. I'm testing your thinking skill. Can you think fast, form your equation fast, and solve it fast? Okay. So let's do this. If you are ready, try to solve this question. I give you 4 minutes. After 4 minutes, I will stop, okay? If you have the answer, just tell me the answer. If you cannot solve, then after 4 minutes, we will solve it together. Okay, let's do it.
D is speed to time. Speed, like the distance of all of his journey is d1 plus d2,
Okay.
but the time is for all distance or only for d1 or d2.
Teacher, I know how to solve this problem. I solved this kind of problem, so it's going to be really easy.
And also, Daphne, I know you know how to solve this problem, and I know this problem is so easy for you. But what I don't know is, can you solve this problem in 3 minutes or not?
For our it's for all distance.
Yeah, Musa, read it and solve it and tell me the answer. Mr. Carson, what's the question? What is the distance traveled for the first part of his journey? Just tell me the distance is this, or I don't know how to solve the problem. You don't have third option. Just tell me these two answers. And my answer is this, or I don't know how to solve this problem.
Done.
Okay. What is the answer, Daphne?
15 kilometers.
15.
Yes.
Are you sure?
No. Wait, I'll look at it again.
Now look at the speed is too. 4 minutes.
Teacher, it should be more than like, it should be, I think, 24 kilometers, a little bit more than the halfway. No, less than the halfway.
Give me one number. What is the distance traveled for the first part of his journey? 10 kilometers, 20, 50, 100, 200,
15.
how many kilometers? 15.
15 kilometers.
Okay, that's your answer. Musa, do you have any answer?
Not at all. Like minus 16 is equal.
No, Musa, tell me the answer. Do you have any answer? Just tell me one number.
Not yet. It's some moves.
Okay, Musa, if you actually, definitely, as I told you, okay, knowledge, the first step. Second step is, what is it? Experience. That means practicing the problems. And third step is we need to work on time. Okay, time management, very, very important in everything.
I have answer.
What is the answer?
15 divided by 6.
Give me one number.
It's not dividing.
What is that answer? 5, 6, 10, 20, 30. What is it?
No.
Okay. All right, Musa. Then, I mean, if you really practice problems
Actually,
and look at this
sure.
idea count so quickly, you know, this formula equation and solve this, that is what I expect from you. Okay. Yes,
Teacher, I think he said like 15 is 6 divided by 15. Wouldn't it be like 0.25 now? How
anyway,
much would it be?
it doesn't make sense. We are talking about the distance. It must be more than, I don't know, I think 50 or something. Anyway, guys, here
There shouldn't be a division there. Anything else but a division. Teacher, these stuff happen to me all the time. Why? Like, you don't, for example, in a question, you're not supposed to multiply them, but I somehow do like 5 multiplications and then divisions and somehow find the correct answer.
You got the correct answer. What's your answer?
No, like the question, once I did a question, it was, I think, some sort of like a question where it said, like, this person went this much like place, and that person went in this hour. How about the place that that person could go in this much hour, like in this much place? Like,
Okay.
it was another easy question. It was a little hard. And then I needed to actually like multiply those by something so that it could be easier, like, and then find it out. I made divisions, several ones, and then I multiplied them each to each other, and then I did other stuff, and I somehow found the correct answer.
Okay.
I
Okay.
it's
Let me
not,
just
I
tell
don't
you.
sometimes understand the overall what question means. I just go one by one and then it gets all messed up.
Okay. And once again, let's just emphasize one thing, Daphne. As you see at the bottom, there's a name of the topic. What is the topic? It is algebraic manipulation and formula. Okay. So here, our purpose solving these problems is not only the solving the problem. Here, we are working on our algebraic skills. Okay. We are trying to improve our algebraic skills. That means that we need to practice using algebra to solve the problems. And now we are preparing ourselves for a more challenging, more complicated, more difficult problems, Daphne. You should understand this point very well. I'm not actually expecting just get the answer, all right? Do you understand the problem number one? Number two, can you convert this into algebraic equation? That's the most important part. That is the skill that we are trying to work on this, okay? And once again, by using this algebraic method, we can solve any kind of question. I mean, even it's very complicated, we can solve this. And definitely what you are saying this, okay, you can just calculate and divide, blah, 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 you can solve. But if the questions are very simple like this, you can solve. If the question is a bit complicated, definitely you cannot solve this kind of problems using that method. Why? Because here maybe your answer is a whole number. Okay, with a whole number you can do this. How about our answer is some kind of decimal number? And how about our answer is very small number or square root of something? Okay, with this calculation we cannot do this. And that's why we need to learn algebraic methods. And we are actually, the question is we can solve in different using different methods very easily maybe. But now we are preparing ourselves for a more difficult, complicated problems so that we can see the relationship between the quantities or variables. Okay. And that's why we need to practice, and you must use algebra to solve the problem. And what does it mean by saying that we should use algebra? You need to read the problem. You have to introduce variables like distance d, speed s, time t, and after the form your equation. That means that now we are using algebra. Now we obtain algebra equation. Then you have to solve this. Okay. We are working on our problem solving skill, not only getting the answer. Definitely, that's the point. Okay, here we are traveling from A to B. Let's say that's the first part of the journey, and from B to C, that's the second part of the journey. In the question already mentioned that the first part of the journey is traveled by the speed s1, the second part by the speed s2. Speed 1 is 54 kilometers per hour, speed 2 is 60 kilometers per hour. The second sentence, it says that he then increases his speed to 60 kilometers per hour for the rest of the journey. Okay, also done. If he travels 225 kilometers in 4 hours, that means 225 kilometers, that's the total distance traveled, and this 4 hours is the total time taken. So that means that if you spend t hours to travel the first part of the journey, that means that you spend 4 minus t hours to travel the second part of the journey. So now 2 to 5 equals d1 plus d2. What is d1? It's 1 times t1. Our t1 is t. And d2 is s2 times t2. Our t2 is 4 minus 2. That's our equation. And what is s1? 54. So here we have 54 t. How about s2? It is 60 t minus 4. What do we got here? Just linear equation, right? We know how to solve this. 2 to 5, 54 plus 60, 114t. minus 60 times 4, it is 240. So from here, 114 is equal to 240 plus 225, that is 465, right? So what is T? T equals 465 is divided by 114. Is that right? So what is it? Can you
I
simplify this?
I did the same, but I didn't write t minus 4. I write 4 minus t.
I see. Let's see. Now, if you divide by 3, this one is 116, it is 5, 15, it is 5, right? Divide by 3, it is 3, 8. Okay. So that is our t. Now, what is the question? What is the distance traveled for the first part of the journey? So that means that we need to find d1, right? d1 equals, what is it? 54 times t. That is 54 times t. What is our t? 155 over 38. So that's equal to 155 times 54. That's equal to, and divide by 38, let's say, is equal to something. What? Okay. Okay, 2 to 5. All right, 54 times t, 60 times. Oh my gosh. Daphne, can you see our mistake?
I think I got the mistake.
Here, right?
Yes.
Because here we got 4 minus t. We wrote here t minus. I was wondering because it's too big number. Anyway,
It means
that's our
that, yes,
4 minus t. It should be 4 minus t. At the time, sorry. Sometimes
yes,
you,
I did this. Yes, I see my mistake. I found t, not d.
you found t.
Yes,
Okay, let's see what we got here. 240 minus 60 t, right? So here we have minus 60 equals, take to the left hand side, 225 minus 240, it is minus 15. What did you get? What is your t?
my t is 15 divided by 6. Yes, this answer.
Oh, I see. Actually, if you got this answer, that's correct then. But anyway, we need to find d1, right? From here, d1 equals, what is d1? 54 times t. Our t is 5 over 2.
1035.
It's equal to 27 times 5. That is 135 kilometers. So what is the
Yes,
question? What is the distance traveled for the first part of his journey? So the distance traveled for the first part of the journey is ... 135 kilometers. Yes, Daphne, we are listening to you. Did you write the same equation, but your equation was different?
My equation was completely different. It's even in a different method. So I learned it sort of in a book that, let's say there's some amount of coins and they ask, and they know the total and you know how much coins there are inside. And they ask, and they tell you that there's two different sort of coins. One is 10 coins and the other one is 5. And you have to, they ask you which, how much is there from both of those. Now, the way that I solve it is I choose the bigger number and then multiply it by the times, or by the amount of coins. And then the leftover, you divide them into the coins, sort of the coins worthy, then you get it. It's
Okay.
it's easy, but I
Yeah.
don't think it worked here for a reason. For some
Yeah,
reason, I don't.
definitely. I understand, but that one is like arithmetic method, you know, in primary school. For example, if you're given this kind of questions, you can just solve like this without using algebra. Also, we can solve these problems. As I told
Teacher,
you,
the
this
point there
algebra.
is because I like to know why I am doing it. Like I like to know why am I doing that? So it helps me to
You are
build
doing
up my
what?
own solution.
Definitely, you are doing what? I don't understand.
So like I like to know learn what I'm doing, why I'm doing it, sort of like till the end, so that I can create up my own solutions while solving the problem. This
Ah,
just
yeah, well, it's
so I
okay.
don't like follow a certain rule or something. Especially like easy problems, I create my own solutions to it,
Okay,
like
okay, definitely.
on
I
my
have one
logic.
question for you. I have one question for you. Okay, let's say you want to talk to your grandparents. Okay, let's say your grandma. So let's say you want to talk to your grandma. How? What will you do now?
I'll call her up.
Huh?
I'll call her up from my phone. That's
So you take
easy.
your telephone and call your grandma, right?
Yes.
So that is the right thing. And you are saying that how about your method is no, no, I don't want to use my telephone. Okay, I want to walk to Istanbul and visit my grandma, for example. Now,
Teacher, what I'm doing is like there's one calling up my grandma from my phone, or I can FaceTime her from my tablet.
oh,
There's two ways. You just have to find it.
yeah, I know. I'm trying to say this one. This methods is verified by many, I mean, not millions, more than millions of people. That is the best way. That's why I just taught the students. You may have different methods. It's good. You may have different methods. You can try. You can use different methods. Okay, but definitely we should be able to compare the methods. That's why we learn different methods. Okay, one algebraic method, maybe some diagram method, maybe graphical method, maybe numerical method. And after that, if you have a problem, and you should be able to compare, okay, which method best fits this problem, okay? Which method is the best one to solve this problem? That's why definitely we have to learn different methods. And when you have a problem, then you have to choose. And
Teacher, I
maybe
don't
among,
learn methods, teacher. I learn questions.
no, 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 now we are learning different methods of solving problems, right?
Yes, but some like I just can't do what I'm told to do. I have to find a different way to do. I mean, yes, there is some like problems that I have to sort of solve going through the solution that's given to me. But then I have to really understand what that solution means and like what's the main idea of it. Like how did they come up with it? Just
Oh,
like so the reason for that is like my parents always used to tell me till the very little speck of the information, even though it was just like a little problem. So I was used to knowing a lot of information and I could create more. That was the reason.
okay.
And I'm sort of
Now,
comfortable
all
with
right.
that.
Definitely, actually, you are right. If you're approaching the problem, why am I using this method? Why are we using this method? That's a good thing, all right, to improve your creativeness, okay? But but it doesn't mean that every time we need to try to find new method. Okay, first, if there's a method, learn it. If you think that it's not the best method, then you have to think about new method. Okay, before learning these methods, you cannot actually create new method because you don't know what methods exist now, right, or available now. Okay, that's why you need to compare. And after that, if I give you just one Samsung telephone, for example, you may see that it's the best. But if you have no idea about other phones, that's the best telephone, right? Now, if I give you five telephones, let's say iPhone, Oppo, Redmi, for example, let's say what else is Nokia, you can use and you can say, okay, among this telephone, this is the best. Why? Because of this reason, okay? And that's why to tell this actual conclusion, you have to learn other methods. You have to use other telephones, then you can compare fairly. Okay, that's what I'm trying to say here. So now I'm teaching you not teaching you. I'm sharing you. Actually, I know this method, and I believe that. I mean, believe that doesn't mean that. Okay, yesterday I tried, and I'm saying this. I have been dealing with math more than 20 years. Let's say more than 25 years. Among this, the algebraic method is the most powerful tool to solve the problems. Now, problem means that we have a lot of problems, right? Related to business, related to economics, related to population growth, related to diffusion of heat, related to engineering, a lot of problems, right? And with different methods, we can solve this. But among the best, actually, the methods, the best method is algebraic method. Without algebra, a lot of problems cannot be solved. Okay, that's why here, what we are learning here is some fundamental techniques of algebra. Okay, all right. Now let's continue. Uh, Now, Musa Defna, using this algebraic method. Okay, now try to solve this question. All right, 4 minutes, guys. Now try to solve fast. Okay, after 4 minutes, we will discuss again. But if possible, read the question, but do not look at this. I mean, uh, as much as you can do it. If you cannot get the answer in 4 minutes, then we will discuss together. Okay, let's start. Also, I will show it on the screen. Okay, I think it's quite easy question, right? Musa, any answer?
No, I searching this. Uh, mm,
Still
yes,
solving.
yes, sorry.
Okay, okay. Daphne, how about you?
Me too, teacher. I'm still solving it.
Okay.
I found X. The X is 12.35.
Good. Daphne, how about you?
Teacher, I'm stuck.
Okay, I think Musa, you got the right answer. I guess it looks like the answer. Anyway, here Abbas buys 30 kg of cheese at a certain price. So that's a problem, right? Actually, what is that certain price? Let's say the certain price is X dollars. And that means that 1 kilo of this cheese is X dollars. That means that here, if you buy 30 kilos of the cheese, each kg is X dollars. Actually, I need just write dollar per kg. Okay, right? So that C is the total cost, right? That we are paying for 30 kg of cheese if 1 kg is X dollars. In the second part of the question, it says that he finds that if he had bought some cheaper cheese costing 95 cents cheaper, right, or less. So that means that now 1 kg is not X dollars, it is X minus $0.95. Then he could have had 32.5 kg. So we could buy actually 32.5 kg for the same amount of money. It says for the same amount of money. What is the price per kg of the cheese? Which is more expensive? Here, which is more expensive? Here, right? The first one. So we need to find X. Now, again, we get very similar equations. Left-hand sides are equal. So now we need to solve this equation. 30x is equal to 32.5 x minus 0.95. So if you remove the brackets and take to the left-hand side, here we have 30x minus 32.5x. On the right-hand side, we have minus 32.5 times 0.95. 30 minus 32.5, that is minus 2.5, and divide both sides by minus 2.5. Here we have minus 32.5 times 0.95 over 2.5, right? And which is equal to, if you calculate this, 32.5, okay, 32.5 times 0.95 and divided by 2.5. That's equal to 12.35. So that is the right answer. So the original price, I mean the price where it was more expensive was, what is it? $12.35 per kg. Okay, that is the price of the cheese. Okay, Daphne, any question?
No, teacher.
Very good. Another question. Okay, this is a little bit challenging question. I really want you to give it a try. Okay, and after that, maybe next question we will solve together. Okay, so we have a bit more questions. Good. First, Daphne, can you read the question, and after that, we will start solving together.
What's that? $M. Oh, okay. $M is just sufficient to pay for the wages of one qualified teacher for X days on the wage of one relief teacher for Y days. For how many days will $M be sufficient to pay for the wages of one qualified teacher and one relief teacher? Give your answers in terms of X and Y.
Did you understand the question?
No.
It's like, for example, let's say, for example, at schools, at universities, usually we have some different types of teachers, right? We have full-time teacher, permanent teacher, maybe let's say part-time teacher. It is something like this. Here it's saying that $M, we have $M, in our budgets, actually, we have $M in our budget, and it says that it's sufficient. Sufficient means enough, right? To pay for the wage. Wage means salary of one qualified teacher for X days, okay? Again, imagine that, for example, your $M is, let's say, $1,000, and you have qualified teacher, and his salary is $500. So for how many months can we use this money? Then we can use this money for 2 months, right? And how about you have another option, and you have one relief teacher, and she works for cheaper. Let's say you just pay for $200 per month. So for how many months can she work for you? That relief teacher, she can work 5 months, right, for $1,000 because you are paying $200 per each month. I mean, per month. It is something like this. So we have in our budget, we have M dollars. So we have two options. If you just recruit, for example, qualified teacher, so that money will be enough only for X days. And how about if you just recruit relief teacher, employee relief teacher, it will be enough for Y days, right? And how about if you recruit or employ both teachers at the same time? Okay, they are not working separately, they're working together. That means that for each month, at the end of each month, you have to pay salary to the qualified teacher and you have to pay the salary to the relief teacher. If it is so, this budget, that M dollars, will be enough for how many days? That means that we have to, what is it? For how many days? Why we have to express this answer in terms of X and Y because these numbers are not given. Okay, so let's solve this together. So that means that one qualified teacher for X days, right? Okay. So in our budget, we have M dollars. Let's say for the qualified teacher, her rate is, let's say it is Q dollars per month. Okay, Q dollars. And for each, not a month, it is days, right? And when he works for X days, we will run out of our budget, right? And again, if I just use the same amount of money for relief teacher, let's say relief teacher's rate is R dollars per day. Now for that money, she can work how many days? She can work Y days, right? The question is, how about if you're using the same amount of money and these two guys work together? That means that I need to pay for qualified teacher and also I need to pay for relief teacher, right? It will be enough for how many days? Let's say that how many days it is T. So from here, the question is, we need to find the value of T. Okay, that is how we model this problem algebraically because this Q is a rate, X is, what is it? It's a time. It's like very similar to distance speed formula, right? So distance is that we have to cover, the speed is the rate, and T is time. And also here, this Q is the rate of qualified teacher, right? For each day, how much we have to give. That's her rate. And I say that, okay, I work for $15 per hour. That's my rate, for example. It is something like this. So how can I find this T from here? Okay, to find T from here, as you see, T is equal to Q, not Q, it is M over Q plus R. Now from here, what is Q? Q equals M over X. And how about R from the second equation? It is M over Y. Now if you substitute these values, these expressions for Q and R, here we have capital M over X plus capital M over Y, right? And the MM is a common denominator. Here we have something like this. M times 1 over M times 1 over X plus 1 over Y. So this MM cancels each other. And if you simplify this fraction, here we will have X times Y over X plus Y. So if these two people, this qualified and relief teachers, they work together at the same time, then for M dollars, they can work only for that many days. What is it? X times Y over X plus Y. And a lot of rate problems actually are solved using similar methods. Okay, Musa, is it clear?
Teacher, it's an interesting question. But it's not a usual, it's an interesting question.
But this actually, definitely, these are, it's a kind of rate problems. And we have a lot of problems in general. Like for example, let me just tell you one question, another problem similar to this. It is solved exactly in the same way. Suppose that here we have a kind of tank, okay, water tank. And here to the water tank, we have two taps, the first tap and the second tap. Maybe this one is big and this one is small, right? And if you just open this tap, the water starts pouring into this container, right? I mean, after a few minutes, it will fill in this container. And if you open the
I
big
hate that
tank,
kind of questions, teacher.
you
Like,
like this kind of
there's
question?
no, I hate that kind of questions, teacher. Like, let it fill. Why do you ask me the time? Just give it some time, it will fill itself. It's not a question. And teacher,
Okay.
I want to ask, like, in the last step, why didn't you just cross over M's?
Yeah, we are crossing here. They are canceling out, right? This M common factors cancel out.
So
Then after that, only X, Y left, right? What is the question? Give you an answer in terms of X and Y. So from here,
it would be like y x y, no, y divided by xy, and then plus x divided by xy. So like it would be x plus y, xy.
okay. So
And
I
then,
take them. Are you
got it. Okay.
right? It is A over B over
And then
C.
you turn it over because it goes to the other side. Okay, yes.
Yes. Okay. Daphne, let me answer your question. Okay, then we'll continue. Uh, it's a very interesting thing, but a lot of students ask like this. Okay, if it's just filling, okay, why we did just let them fill in the container? Okay, if you just approach the problem like this, you are right. Okay, but here in a big scale, okay, if you're working in a company and you are painting something or you are filling in a big tank, right? But you need to write a program, for example. I want to know the exact time. I know the rate of one pipe. I know the rate of the second pipe, right? If I just open this, how long does it take? I should know this, number one. Number two is, you know, the big petrol tanks, for example, the big trucks, right? They carry the petrols or gasoline or gas, whatever it is. They just distribute this to gas stations, right? At the time when they just want to fill in the big tank under the ground, they just put the pipe and after maybe they know the rate, you know, after exact time, they should just automatically stop it. Okay. And this kind of engineering problems, you must know the exact time how to evaluate this. Because in engineering problems, we do not, how to say, uh, let's say approximately one person comes and says, okay, I want to work for the company. And you ask, what can you do? And he says, I can paint the walls, for example. And you ask, okay, in 1 hour, how many square meters of wall can you paint? And he says, in 1 hour, I can paint, for example, let's say 15 square meters of wall. So that is the average rate of the worker, right? Now you have to estimate, okay, now because you are the house owner, and maybe you're going to have a wedding or kind of party. So by the time of the party, they must have finished their job, right? And you have to evaluate, okay, in how many days we can finish? How do you evaluate this? If one worker comes and works, okay, it takes 20 days. How about if you employ 5 workers? I mean, these are very, very simple engineering, but very important problems. And that's why in a lot of predictions, okay, estimation, we should know how to evaluate these things. That's why these problems are given. Okay, guys, Daphne, let me finish. Here we have, again, I was going to finish this. We didn't finish. There's one question. Let's solve this question and I will finish today's class. Okay, again, first you try. Okay, let me give you like 4 minutes. If you solve it correctly, I will finish the class. If your answer is not correct, then we will solve together and finish the class. Also, this is one real life problem from business. It's like currency exchange. Okay, this question 17. Read it and try to understand and solve it. After 4 minutes, we will discuss together. Okay, time started. Also, I will solve this in the paper.
What's mean S dollar? Teacher, I can't understand. S
Mu-
dollar. What's mean?
Musa,
That's
here,
Australian
what?
dollar. That's
S dollar.
Yeah, very good.
That's
That's correct.
Australian dollar, right?
That's
Australian
AU,
currency.
Australian dollar. How about this S? Singapore dollar or Singaporean dollar. Because now we have New
Singapore,
Zealand, also they use dollar. Singapore, they use dollar. Australia, they use dollar. United
teacher,
States, they use dollar.
in,
Yes.
in Singapore, why did they use dollar?
Actually, they use their own currency, but they call this currency Singaporean dollar. Like, for example, lira, Turkey uses lira, right? It's Turkish lira.
Yes.
Also,
Turkish lira.
Italy, they use lira. It's Italian lira.
Do they use? I
course,
didn't know that.
Italy also, they use lira. For example, if you go to Central Asia, Uzbekistan, they use som. Kyrgyzstan, also they use som. But these are different money, okay? But their currency, they call like this.
So it's, but what is the actual meaning under this? Like, I know they're not like words. I think they're words coming from like other languages.
No, it's just a currency name.
currency.
Maybe history, it must be some historic, actually, how to say, base, but it's how they call their currency. Of course, actually, maybe it means something, I don't know. Like Russia, they
Sure.
call ruble, that's just currency name. Yes.
Is Australian dollar and like American dollar the same?
No, they are different. Singaporean dollar, very different. American
No,
dollar,
like
very
the
different.
rate and the stuff. Is it like, is Australian dollar cheaper or like,
Yes.
I mean, it changes, right?
Yes. Australian dollar is
It's
cheap.
not like you.
$1 US is about 1.35 Australian dollar.
It's not like euro then. Okay.
And euro is more expensive than dollar, but Singaporean dollar, that New Zealand dollar, Australian dollar, they're cheaper than US dollar.
But teacher, in Europe, European countries like who are accepted as European countries, they use all like euros.
Okay.
But like then it doesn't change in countries. So like overall, if let's say like a country collapses in Europe, and then like what happens to euro? Does it also like gets less? But then it's unfair to others.
No, what do you mean collapses? What do you mean?
Like by collapses, I mean like the economy gets really bad and like there's now not that much other dollars including in there and like stuff.
Yeah, that's why actually the existence of European Union is to support each other in difficult situations. If, for example, like Greece, right? Actually, they have very bad economic crisis, but the European Union, they help a lot. They give a lot of money, right, to support actually their economy.
But teacher, I get that. But the thing here is that it's so different. Let's say one country collapses, like Germany mostly will never collapse that much since it's like a little bit powerful country. But like a small country collapses, then people give them their money, and but even though like nobody helps them actually, isn't it unfair?
Yeah, actually, this is a big topic, definitely. Here, European Union, for example, they have a lot of conditions, right? And they have a lot of mutual benefits. Okay, I mean,
That's why Turkey can never ever be in European Union.
yeah, I mean, in Europe, for example, one country is going into crisis. It's not like, okay, today, tomorrow, they bankrupted. Okay, it's not like that. It happens. It happens over the years, maybe in 5 or 6 years, because we are talking about a big country. But during this time, European Union, they don't just watch. They just warn them, okay, you're going into something, I mean, bad situation. So they suggest a lot of things. It's not that easy stuff, okay? They just don't watch. They have experts and they try to help their allies as much as possible. And that is the existence of European Union, to support each other in difficult situations. Otherwise, why people, I mean, countries want to be a part of this union? And their system is so powerful, that's why they try to be a part of this union. Okay, here, let's get back to the
Okay.
question, Daphne. Here, Musa, these are
To
different
one country gets
currencies.
out of it, the other ones are like, please let me in. Life is so unfair, teacher.
Yeah, let's not, it is unfair. Also, there are fair stuff, but to be absolutely fair in this world, it is not easy stuff, I think. You get a lot of unfairness, definitely,
Not
but what we
possible,
think
teacher.
is we try to be a good person, and my goal in life is I try to share my knowledge with as many people as possible and give a good, how to say, try to provide good education to my kids, okay? And I try to be a good teacher, try to be a good father, a good son or good brother, something like this. And at least how much we can change around us, we have to focus on this, okay? And far away from you, if you just keep thinking and maybe years pass, we cannot make any change. You want to make a change, start with your surrounding, okay? Among your friends, maybe teacher.
Teacher,
Yes.
I came to the conclusion that like maybe yes, there's like this stuff where you will be like if you do bad, it's bad. But if you do good, you will be rewarded. Like, but then it's all just a story too. Like bad and good is sort of like written in people's minds. So if you do something bad to them, they will write it down. If you do something good to them, they will write it down. And that's how it comes to the conclusion. People mix like God and like religious stuff into this and say like you do good, God will give you good stuff. You do bad, God will give you bad stuff. Like it's not about what you it's not about like what you do, it's about how you make others feel. Even though you're in a very very bad like mood, it's always like better to put up a smile even it's fake, then people get like happy, because knowledge, happiness, all of those sorts of stuff, they all get more when you share it.
Yeah, of course, that's right. And that's why actually to be, I mean, to achieve those stuff, definitely I believe that education is the best solver. As people get more educated and they have better friend around them, and it is very hard for them to go in the wrong way, okay? And let's see, it's a lot of people, they don't have a good environment, that's why they choose wrong path, maybe unwillingly, because of their friends, okay? They have to follow their friends, they cannot actually just isolate themselves from their friends, and they just go the wrong way. Okay, good. Definitely, really thank you very much for sharing your thoughts. Let's finish this question, okay, quickly, and also finish our class. Anyway, Musa and Daphne, maybe Daphne, the here. And Musa, when you come here, you will see that everywhere, every country, they have different currencies, right? In Malaysia, they use ringgit, Singapore in dollar, Australia. So when you just come and when you just step in, that means that in Malaysia, you are not allowed to use any foreign currencies. You must use local currency. That means that you need to exchange your money, right? And let's say you come to Singapore, let's say for a visit for, let's say, SASMA Olympiad, and you have a 4-day program. And in Singapore, you are not allowed to use, in, let's say, Turkish lira or Azerbaijan, or how do you call Azerbaijan money?
Math.
Huh?
Manat, teacher, manat.
Manat?
Yes, manat.
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 How about Turkmenistan? Do they also use manat?
I'm not sure, but
What?
it must be something like that.
Turkmenistan.
I
Let
didn't
me look it up.
I didn't hear you. What did you say?
Yes, also Turkmenistan, they use manat.
Yes, they also use manat. Turkmenistan manat. This is Azerbaijani manat, and that one's like Turkmenistan manat.
Yeah, because I have
Why
a
do
lot
they
of,
use it, teacher? Again, is it because of the like dynasties and stuff? Like because once those grounds were like theirs and stuff. Actually, no. All of Azerbaijan was also covered by like yes.
maybe during that time, some ministers, they have a kind of meeting and they choose this. Maybe or manat in Azerbaijan language and Turkmen language, they mean something valuable. I don't know. But actually there are a lot of the similar currencies. As I told you, Uzbekistan, Kyrgyzstan, they use som, but the som again different. Also Turkmenistan, Azerbaijan manat, but your currencies are different, right? Just names are the same. Turkey and Italy is also interesting. What is the connection, right? But also they use lira, but different currencies. Anyway, it is something like this. What I'm trying to say here is when you travel to these countries, you must change your money at the airport, let's say, and you stayed in Singapore for like 3-4 days, and you just brought $1,000 and you just change this. Let's say now $1,000. Now you have 1,400 Singaporean dollar, and you only use 1,000 Singaporean dollar. Okay, now you have to go back to Azerbaijan. So in Azerbaijan, you cannot use Singapore dollar, right? Now you have to change back again to US dollar. So at that time, every bank they have buying and selling rates, right? Maybe when you're buying this, it is expensive. When you're selling it, it will be very cheap. It is something like this. What actually makes, banks make profit. Anyway, here the exchange rate for Australian dollar in January 2017 was 100 Australian dollar was X Singapore dollars. Okay, so that's the first one. Let me just write here. Where is my marker? January 2017. And the rate was 100 Australian dollar was, what is it? X Singaporean dollar. So in June 2017, and we are talking about June now, the exchange rate had become, what is it? 100 Australian dollar become, it is X minus 5 Singapore dollar. John found that he could get an extra 32 Australian dollar for every 672 Singapore dollar that he exchanged in June compared to January. Okay, form an equation in X and solve it. All right, so that's the question. If you understand the problem and you need to solve this question first, okay, that's your homework. Let me just stop here, and also a little bit brainstorming, because not difficult, but when you solve this question, you will get a quadratic equation, okay? Then you have to solve and answer this question. It's a little bit challenging question. Not every
I
student
didn't
understands.
understand it.
Huh?
I didn't understand it.
Okay, definitely. Did you understand?
Yes, teacher. It's not that challenging though.
Yeah. Here,
Simple currency.
yes. Musa, here at two different cases, right? Different days you're changing. In January, X dollars, and June it is X minus $5, right? So that means that in June, in which case Australian dollar is cheaper? In June, right? As you see here, for example, here it is X dollars. Now for the same amount of Australian dollar, you are getting less Singaporean dollar. So that means that there is a decrease in the price of Australian dollar. Okay, let's read the second part. John found that he could get an extra $32 for every 772 that he exchanged in June compared to January. Form an equation in X and solve it. Okay, let me just write here. Okay, here. All right, let me just draw this. Okay, good. So now from here, John found that he could get an extra 32 Australian dollar, right? For if you just change $672. Okay, here we have the first case, right? Australian dollar. So 100 over X Australian dollar is how much? It is 1 Singaporean dollar, right? And how about here? Australian dollar, it is 100 over X minus 5 is equal to, here we have 1 Singaporean dollar. I just divided here the both sides by X, in the second case, X minus 5, right? And now if you multiply by 672, what we have here, 672 times 100 over x is equal to, on the right hand side, not equal actually, I can write, here we have, what is it, Singaporean dollar, 672. And how about if you just change the same amount of money in June, you would get 672 times 100 over x minus 5. And again, if you change 672, right? Now, what is the difference between this Australian dollar? What is the difference? The difference is 672 100 over x minus 5 minus 67200 over x, that's equal to 32, right? That means that, Musa, if you change 672 in January and again 672 in June, right, you're just changing Singaporean dollar into Australian dollar. So the difference in the amount will be $32. That's the difference. That's the difference between these chains. It is $32. Okay, now we need to find this x. What was the rate in June and January? That is our quadratic equation.
Thank you.
Good. You try this. Okay, try to solve this. I mean, if you can solve, you can just take a picture and send it to me. If you solve before our next class, today is Wednesday, right? We have class on Monday. Good. Okay, Daphne, Musa, thank you very much.